Ramanujan meet Friedmann. Now we take the Einstein field equation, where the left-hand side represents the geometry of space-time, while the right-hand side represents matter-energy. Now let's isolate pi. From the following Ramanujan's modular equation, it is the result. This is a modular equation that approximation to pi. Choose we have that from this expression and the previous expression, the result of both expression is pi. Choose we perform the following calculation. This is the expression. This is the exact result. The alternate forms. Alternate forms assuming that the various parameters are positive. The expanded logarithmic form. Alternate form assuming g non equal to 0 and t non equal to 0. The root for the variable t, the derivative, the indefinite integral. Now, from the indefinite integral result, practically the right-hand side of the integral, we obtain from the following expression the following alternate forms. Expanded logarithmic form, the alternate form assuming g non equal to 0 and t non equal to 0, the following roots. The root for the variable t, the derivative, and again the indefinite integral. In this calculation, we obtain also the limit and further alternative representation. From the above limit, we obtain a new possible formula from pi multiplied speed of light, practically. Furthermore, we obtain also from this formula the following expression. We note that 2000, 15.3, and 7 are respectively a Fibonacci numbers and a Lucas number. This is the result of this expression. Practically a result that is a very good approximation to the value of the golden ratio. That is a Ramanujan recurring number. Also for this expression we obtain the alternate forms. From the above root, precisely this root, this result of t equal to this expression, we obtain for g equal to the speed of light, g equal to the value of the gravitational constant, we obtain the following expression. The following expanded form. The alternate form, assuming that is variable are real. The alternate forms, the roots, integer root, the root for the variable r, the derivative, the definite integral, over a square of edge length equal to ql. From the previous expression, for this value of g, where this number is the value of the following Rogers-Ramanujan continuous fraction, we obtain the following expression, the following plot that represents the above expression, the alternate form, assuming R is real, the property as a function, the derivative, the indefinite integral, and the definite integral of subtraction of diverging parts. From the above expression, for R equal to 1, multiplying by 18, performing the natural logarithm, adding 47 and subtracting square root of 2 multiplying Napier number, we obtain the following expression. That is the following. We note that 18, 47 are Lucas number. The result of this expression is a result that is very near to the Hardy Ramanujan number, 1729. That is a taxicab number. Practically, it can be expressed as the sum of two cubes in two different ways. Furthermore, this result is very near to the mass of a candidate glue ball F0 1710 scalar measure. Furthermore, 1728 occurs in the algebraic formula for the Jane invariant of an elliptic curve. And also this number is a Ramanujan recurring number. Since bosons are made of gauge bosons and scalar bosons, mesons, then this number, theoretic analysis, perhaps confirms that the number 1729, confirm the fact that both the gauge and scalar bosons are actually different states of a single bosonic string, and that these states are isomorphic, or that the state's vibrations are synchronized with the state of the bosonic string. This also implies that each state lies inside a cubic or octahedron as a spherical tube, and that the total sum of these two states is the state of the bosonic string. Taking the cross-section of the bosonic string, we realize that it must be a rectangular or a two-shaped octahedron. As the string vibrates in different frequencies, so the two spherical cloud states inside the string. That is, the string vibration simply excites the gauge bosons, E, photon, gluon, W and zeta inside one cube octahedron, and the scalar boson, practically Higgs, inside the other cube octahedron. Furthermore, if we bring the picture of loop quantum gravity with the property of a discontinuous quantum geometry, we can therefore think of graviton living on the vertices of the rectangle of the octahedron. This graviton then acts a glue binding the bosonic strings lattice together, forming a complete cross-section of alternating states of between the Gauge boson and the scalar boson. This arrangement of states then gives a precise supersymmetric quantum picture of the vacuum geometry at low entropy. But the geometry further reveals a very important fact, that since the vacuum geometry is discontinuous, then we observe that there is no relation whatsoever between the quantum vibrational frequencies of the strings and that of the vertices of the vacuum geometry where the graviton lies. As Steger and all assert that gravity is simply a manifestation of space-time geometry, thus the graviton cannot be a string boson. However, there is a duality between gravity and strings. Also, gauge bosons have spin 1, while the graviton has spin 2. Then, lastly, because of the thermodynamic constraints, we were able to arrive at the result. We have now this intrinsic aspect of complete quantum gravity theory. We are after that is without the other no complete and compelling quantum geometry can be attained as it is done here, is need to be investigated further. From which the previous expression, easily we obtain also 4096 and the value of the zeta 2. Indeed, from the following expression, we obtain the following result. It is a value very near to 4096. That is also a Ramanujan regarding number that when multiplied by 2 gives 8192. The total amplitude vanishes for gauge group SO 8192. The bosonic string SO 8192, while the vacuum energy is negative and independent of the gauge group. The vacuum energy and the dilaton tadpole to lowest non-trivial order for the open bosonic string, while the vacuum energy is non-zero and independent of the gauge group. The dilaton tadpole is zero for a unique choice of gauge group. Practically SO 8192. From this expression, use for this expression, practically performing the 15th root of the expression and adding the following regularizer that inside there is the Marvin-Rayburn constant, we obtain the following result. A value very, very near to zeta 2 that is equal also to pi squared over 6. Practically, we obtain the trace of the instanton shape and also Ramanujan regarding number. Choose the new results that we are obtaining from the Einstein field equation, isolating pi and using a Ramanujan modular equation, which results in a very good approximation to pi. We get pi multiplied the speed of light in vacuum, and the Ramanujan regarding number zeta 2 pi 1729 and 4096. A Friedmann equation analyzed by Ramanujan's mathematics. We analyzed the following Ramanujan modular equation. For the following Ramanujan's formula for pi, we obtain the following expression. That is decimal approximation. We obtain the following very good approximation to pi. That is a Ramanujan recurring number. This is the property, practically, that pi is a transcendental number. From the right-hand side of the following second Friedmann equation, which is derived from the 0, component of the Einstein field equation, where A is the scale factor, G, lambda, and C are universal constants. G is the Newtonian constant of gravitation. Lambda is the cosmological constant with dimension length raised to -2, and C is speed of light in vacuum. Rho and P are the volumetric mass density and not the volumetric energy density, and the pressure, respectively. Cap is a constant throughout a particular solution, but may vary from one solution to another. Considering the following Ramanujan approximation to pi, let's rewrite the Friedmann equation and obtain the following expression. The exact result of this expression is the following. Also here we obtain alternate forms, sorry. Expanded form, further alternate form, derivative. Now, from the derivative result, practically the right-hand side of this equation, of this expression, we obtain the following expression, the following plots, the following alternate form, a further alternate forms, 1 and 2, the expanded logarithmic form, another further alternate forms, the property as a function parity, the series expansion at C equal to 0, the series expansion at C equal to infinity, the derivative and the indefinite integral, the limit. Again, from the second derivative result, practically the right-hand side of this expression, we obtain for the value from the value of gravitational constant and the value of the speed of light the following expression. That gives the following result, from which, after some calculation, we obtain the following expression, where this term is equal to this value. And the result practically is equal to Planck length. But we can obtain the same result also in this other way by the following expression, and the following expression multiply the following term, the following, where 2 and 3 are Fibonacci prime numbers, Fibonacci prime numbers, and also from this expression we obtain a value very near to Planck length, practically equal to Planck length. The conclusions, starting with the Friedmann equation, which is derived from the 0, component of the Einstein field equation, and using Ramanujan approximation for pi, we obtain results that are remarkably close to Planck length, which is about this value. This shows how mathematical formulas, when manipulated precisely, can reflect fundamental physical constants. This connection suggests that the Friedmann equation, which describes the expansion of the universe, and Ramanujan's formulas, which emerged from numbers theory, may share a common mathematical structure. This code led to new insights in cosmology and theoretical physics, unifying cosmic and quantum scales in unexpected ways. Thank you very much. Thank you very much.